Hello everyone, this is Sandeep Singh. Welcome back once again in your favorite channel. I hope you are doing very well and we will going to discuss in today's session physics toppers package. Alright, this session is basically designed for those students who wants to achieve their 95% of his score in second PUC board. Alright, so first of all, just let me know in the chat box, audio and video is proper. Okay, it's fine. I hope audio and video is proper. Hello everyone. Hello, hi. Okay, that's great. Hello. Yeah, let's begin today's session. Yeah, let's begin today's session. I think screen is visible properly, so let's begin today's session. All right. Yeah, obviously see, basically today we will going to discuss most important questions plus PYQs plus sample paper questions along with your toppers answer sheet. All right, I have your topper answer sheet also, so that you can see how to write answers properly in board examination, so that you get maximum marks in your board. Right, so it's about one and a half hours. All right, so let's begin. Don't worry, Amina, don't worry. We're going to discuss each and everything in detail, right? So don't worry. Okay, fine. Let's begin the session. Just put a thumbs up in chat box. Then after we will start the session, right? Okay. Don't worry, students. Don't worry, champions. Don't worry. Yeah. Okay. Let's begin. Yes. See. The PDF notes available in the description, available in the PDF format, and the link given in chat description box, right? So you can download your PDF notes from the description box. All right, fine. Let's begin. Most important PYQs first, then after we will discuss most important sample questions, and then after we will discuss or we can just see your toppers answer sheet. All right, okay, students. See, I just show you the questions on screen. Let's try to solve these questions in chat box. Right, so the very first question is: the electric dipole is placed in uniform electric field is unstable if the angle between electric field and dipole moment is. See, when it is unstable, as you know very well, if a dipole is kept in uniform electric field, then there is a torque acting on that is tau equals to PE sin theta. That is tau equals to PE sin theta. All right, and if I am going to discuss the stability of this tau, it will depend on this theta. Now theta is equals to 180 degree, then sine 180 degree. All right, this is sine 180 degree. This one is unstable case. And if I'm talking about theta equals to 90 degree, in this case, as you know, sine 90 is 1, which is maximum. That is the case of tau max. But here instability, and instability comes under sine 180 degree. Sine 180 degree. That's why at 180 degree, this value is negative of 1. D option is the correct one. All right, D option is the correct one. Now moving to next question. And the second question is Maxwell's modified form of Ampere circuital law. Maxwell's modified form of Ampere circuital law. Just try to answer first one, second one, third one, and fourth one. I think first one and second one, as you know, this is not possible, right? Third and fourth, just see And answer please. 0 is not a stable case. In that case, see Nick, in that case, if you are considering sine 0, in that case, torque is 0 basically, right? We are going to discuss unstable case. See. I just draw. If you want, see, I just draw. See, if I put a dipole, see, this way, P is in the direction of electric field. This is how theta equals to 0 degree, right? In this case, you have sine 0, which means 0. Tau is in this case 0. But what we talking about, see, this is your uniform electric field, and we are just skipping the dipole in this way, so that the direction of P vector is the opposite of the E vector. Here theta is equals to 180 degree, right? Here theta equals to 0 just because P is in the line of electric field. Here P is just opposite to this, so that sine 180 degree is the most unstable. Okay. Now moving to next. So many of you try D option. D option is the correct one, right? B dot dl is equals to mu naught times of I. This is basically Ampere's circuital law. And this one comes from the Maxwell's modification. Maxwell modification is what? This is basically current in free space, right? Current in free space, that is Maxwell current. This is Maxwell current. All right. D option is the correct one. That's great. D option is the correct one. Now moving to next, the magnitude of drift velocity per unit electric field. See, magnitude of drift velocity per unit electric field. What it is? It's mobility, drift velocity, relaxation time, or resistivity. See, as you know very well, resistivity is just a RA upon L, where these two equivalent to 1. All right. So that rho equals to R. And what about drift velocity? In drift velocity, this is VD. That is the average velocity. And they are given drift velocity per unit electric field. Yeah, obviously A is the correct one. Nick, your answer is correct. Yaswini correct. Suresh correct. Yeah, Saujanya correct. Okay, yeah, that's mobility. Yeah, that's great. Moving to next. Now, questions from 2019, right? Questions from 2019, and what it is, write the expression for force acting on a moving charge in a magnetic field, right? F, which is equals to Q B cross V. Is it? B is it's a uniform magnetic field. V is velocity and Q is charge. This is the force acting on the moving charge in uniform magnetic field. All right. Okay. Write the expression for de Broglie wavelength of electrons in terms of electric potential and explain the terms used. All right. Okay. See, this one, Q equals to V cross B vector, that is QVB sin theta. And the second one, de Broglie, that is lambda equals to H upon under root of 2 MeV. Lambda is what? It's de Broglie wavelength. H is what? It's Planck's constant. M, mass of electron, and V is the potential, and E is the charge on electron. Okay? Done. Now moving to next. What is NAND gate? Give its logic symbol. What is NAND gate? NAND gate is basically AND gate and plus NOT gate, right? NAND gate, that is, see, this is basically NAND gate, right? This is NAND gate. All right. And if I'm talking about the truth table, I think it's not asking, it's about 2 marks, right? Then y equals to a dot b, and y equals to a dot b bar, that is 0 0 1 1 0 1 0 1. This is the way to write your truth table. 0 any of input is low, then output is low. 1 1 1. And what about this? 1 1 1 0. Right? Okay. Yeah, that is basically from 2017. That is from 2017, right? Now, second one, arrange the following electromagnetic waves in ascending orders of their wavelength. That is radio wavelength, radio wave, gamma rays, infrared waves and X-rays. And what it is in ascending order: gamma rays, then after X-rays, then after infrared, then radio waves. Okay, got you got your point. Okay. Now moving to 2018. 2018. See, if the peak value of AC current is 4.24, that is the value of I naught, that is 2.424. What is the root mean square? That is I RMS, which is equals to I naught upon root 2. Okay, I got your point, right? I naught upon root 2, that is 4.24 upon root 2. Is it? Okay, it's fine. Write the relation between magnitude of the electric and the magnetic fields in electromagnetic waves. Right? And third one, give any two application of X-rays. See, this one is basically 2.99 and this is under root of mu naught upon epsilon naught times of H, electric field and magnetic field. And the two applications of X-rays, that X-rays are used in medical diagnosis to find bones fracture, lung TB, gallbladder stone and kidney stone. They are employed in engineering to inspect bridge defects. Right? Yeah, PDF notes available from the link in the description box. Right? Deepak? Now next question. What is a rectification? With relevant circuit diagram and waveforms, explain the working of PN junction diode as a full wave rectifier. See, if I'm talking about rectifier, rectification is what? This is used to convert AC in DC. This is the main functionality of a rectifier. You can download PDF notes from the link given in description box. All right. After the session, just because I'm just uploading this PDF notes after completing my session, right? What is rectification? Rectification is just AC converted into DC. Now, see the working of PN junction full wave rectifier, right? See. This is a transformer and here this is input signal source, that is called VI, Vin basically, right? This is basically transformer. Let's complete the diagram of transformer. In full wave rectifier we are using two diodes in this way, and the transformer is basically centrally trapped. This is a central trap transformer and this is basically RL, so that this from here we can calculate VL. VL is what? It's load resistance. It's load potential, right? And this is called RL. RL, that means it's load resistance. This is the diode D1 and this one is called D2. Now just see, just focus on the color combination, just because I am using this diagram for the both phases. So stick on color combination. See, an AC source connected at input end, and here can we put this point as a, this point as a B, this point as a C, this point as a D, and this point as a E, this point as a F, right? A, B, C, D, E, F. Now see, if first half of AC signal comes at input end, that one is this one. See, at this time, if I'm considering AC signal source in this way, then This is at higher potential. See, this is at higher potential, this is at lower potential, right? In the same way, if I'm considering this half, then this one is at lower potential and this one is considered at higher potential, right? That's why it's called AC, right? Alternating current. Now see, for this one, Deepak, once I complete the session, then after I upload the session PDF, right? Before that, how can I upload scrabbled your PDF notes, right? With the annotation, PDF notes available only after the class, right? It's just common sense, right? See, if I'm talking about this positive phase, right? This one is at higher potential, this one is at lower potential. See the working. For first half of AC signal, A is at higher potential, A is at higher potential, B is at lower potential. That is, A is at higher potential, B is at lower potential. So that if A is at higher potential, then F is also at higher potential, C is also at lower potential. Then at higher potential F, lower potential at C. So that what do you see? D1 is in forward bias, just because this one is positive, this one is negative, that's why it's called diode. D1 is in forward bias. And what about this? The P type of material of this diode D2 is at negative connection and here positive, that's why it's called D2 is in a reverse bias. So that only this one conduct output, this one not, open. And what is the path? Current from here to this central transformer, circuit completed. And this one behaves like a open, this one behaves like this, right? But see, I just plot a VI characteristic, or you call input and output waveform. This is basically input, and at bottom I just draw output. See, I'm just drawing this the frames. This is the frame basically. See what I'm talking about. See, for the first half of AC source, diode D1 conducts so that at output we have at output signal. Now I'm using different color for the next waveform, that is green, right? See, if I'm considering this negative half, at negative half, B is at higher potential, A is at lower potential, A is at lower potential, B is at higher potential. This is basically transformer, so that F and A have the common potential, C and B have the common potential. So that D1 is now a reverse bias and D2 is now forward bias. So this one conduct and this one behaves like. So this time also I have output potential, but this one is due to D2 and the direction of this current is the same like this way as above. So that the negative phase inverted to 180 degree at a positive type. See, again this wave from D1 and this one from D2. So you can say D1, D2. This is called full wave rectifier. Right? This is the complete theory of full wave rectifier. That is the process in which both the halves of AC rectified to be obtain a pulsating direct current is known as full wave rectification. A transformer with central trap used for the full wave rectification and working same like as we discussed, right? This one is the input and output character. Now, write the three postulates of Bohr's atomic model. Three postulates of Bohr's atomic model. Three postulates of Bohr's atomic model. See, Bohr's atomic model, an atom has central positive charge of nucleus. Electrons revolve around the nucleus in circular orbit called stationary orbit. The necessary centripetal force is provided by the electrostatic force of attraction between the nucleus and the electron. This is the first postulate. Second postulate, in the stationary orbit, angular momentum of electron is equal to the integral multiple of h upon 2 pi. H is a Planck's constant. That is, mvr is equals to n times of h upon 2 pi. N is basically shows quantization rule, Bohr's quantization rule, right? Okay. Now, the third one, the electron radiates energy only when it jumps from one orbit to the higher orbit to another of lower energy, right? That is nu equals to E naught minus E1 upon H. These are the three postulates of Bohr's model. Done? Done? Okay. Okay. Bhumi, basically these are the most important questions. These are the most important questions. Most of the questions expected in your final examination, and that proof check, for the proof check, we have toppers answer sheet also, right? So you can just see these questions in your in that toppers answer sheet also, right? That's why we called this session leads to 95%. This session secure your 95% in your PUC second exam, right? Okay. Now moving to next, this is basically alternative question of this one, right? See, obtain the expression for effective EMF and effective internal resistance of two cells connected in the parallel such that the current flowing in the same direction. And the second one, that is in OR, two cells of EMF E1 and E2 internal resistance R1 and R2 connected in the parallel so that they stand together in the same direction, derive the expression for the equivalent EMF of the combination. All right. See, let's draw. I have two cells. This one is these two cells connected in parallel. Also, I have an external resistance of, all right, EMF E, resistance R and R, right? E1, E2 and R1, R. Just put it here. This is E1, E2 and this one is R1, R2. In parallel combination, as you know, the EMF will be same. That means across this resistance EMF will be same. So that just let's calculate the current from E1 and current from E2. Current from E1 is what? I1 equals to E1 minus V upon R1, and current from I2 is E2 minus V upon R2. This one is basically EMF, this is potential difference. EMF minus potential difference upon resistance. EMF minus potential difference upon resistance. Is it? Okay. Okay. Today's, what's the exactly problem? Okay. In which question you have problem? In which question you have problem? So let's see the total current in parallel combination. In parallel combination, you know that I equals to I1 plus I2. I just calculate both I1 and I2. I1 and I2 from where? I1, that is EMF minus potential difference upon R1. All right. I2, which is E2 minus V upon R2. All right. Okay. So this, I think English is comfortable to all of you. I think English is comfortable to all of you, right? Yeah. Just because you are an English medium student, right? So let's put I1 and I2 here. So I is equals to I R1, I equals to E1 minus V upon R1, E2 minus V upon R2. Take the LCM of R1, R2 and put it here. I R1, R2, that is E1 R1, R2, E1 R1 minus R1, R2 times of V. Just V equals to this V, E1 R1 plus E2 R2 upon R1 plus R2 minus I R1 R2 upon R1 plus R2, right, equals to E1 R1 R2 plus E2 R1 upon R1 plus R2 and R equals to R1 R2 upon R1 plus R2. This is the expression which we want. All right. Done. Moving to next. Okay. Fine. Now moving to next. This is the questions from 2019 and this is 5-marker question, right? In Young's double slit experiment, wavelength of light used 5000 angstrom and distance between two slits is 2 mm. Distance of a screen and the slit is 1 meter. Find the fringe width and also calculate the distance of 7th dark fringe from the central bright fringe. See, wavelength lambda is equals to 5000 angstrom. What is this value of angstrom? That is 10 to the power 10, right? And this is distance between two slits, that is t, that is equals to 2 mm. Now it also converted into 10 to the power minus 3 meter. Now screen, this is the value of capital D. This one is 1 meter. This one is 1 meter. Right? This one is 1 meter. Okay. Now just put beta is equals to lambda d upon d. Beta equals to lambda d upon d. We have the value of lambda, we have the value of capital D, we have the value of small d, and calculate. This is 2.5 into 10 to the power minus 4 meter. And what about the 7th darker fringe? Distance of nth darker fringe, that is xn equals to 2n minus 1 beta upon 2. N equals to 7 and beta equals to 2.5 into 10 to the power minus 4. Just put it here. This one is 2 times of 7, that is 14 minus 1. Beta is basically this one, 2.5 into 10 to the power minus 4, or you can say 2500 into 10 to the power c. This value can be written as 2500 into 10 to the power minus. Okay. This is 1.6 into 10 to the power minus 3. All right. Okay. Okay. Is there any problem with anyone? Is there any problem with anyone? Now, explain how galvanometer is converted into an voltmeter. See, galvanometer is converted into voltmeter by using shunt resistance. Right? And in galvanometer, we use shunt resistance in series combination. With galvanometer, we use shunt resistance in series combination. And what is the value of this resistance? This resistance having maximum value. Okay, this resistance having maximum value. See. Moving coil galvanometer as a voltmeter, its resistance should be increased to desired value and the arrangement should be provided to measure large potential difference. This achieved by the connecting high resistance in the series combination of moving coil galvanometer. Moving coil, this is the resistance of galvanometer and this is basically shunt resistance, right? So that V equals to GRS plus IG. Potential difference V is equals to G plus R S into I. All right. Okay, it's fine. See, V equals to Ig, G plus Rs, that is Z plus Rs equals to V upon Ig. If I'm talking about Rs, that is V upon Ig minus G. Right? Okay, fine. Moving to next, mention significance of Lenz law. Significance of Lenz law. As you know, phi is equals to, basically, equals to d phi upon dt. A rate of change of electric field leads to EMF across the solenoid, and Lenz tells that is it's negative. And what this negative source? This negative source, it opposes to the cause. All right. Write the expression for the natural frequency of oscillation in LC circuit. LC circuit. Okay. See. Lenz law gives the magnitude and direction of the electric current induced in the coil due to change in magnetic flux through that coil. Right? And if I'm talking about the frequency, then what it is basically 1 upon omega c is equals to omega L. 1 upon omega c, as you know, see, omega L minus 1 upon omega c, which is equals to 0, right? If you are not comfortable in this, this is called Z. In LC circuit, Z becomes 0. That's why omega L minus 1 upon omega c, which is equals to 0. Then omega L is equals to 1 upon omega c. Just keep omega at a side. That is omega square, which is equals to 1 upon LC. Now, omega is equals to under root of 1 upon LC. Omega is basically 2 pi f. That is 1 upon under root of LC. All right. Okay. Okay. I think it's not visible, right? Yeah. It's not visible to you. So I just solve this. See, from here. Omega L, which is equals to 1 upon omega c. Now omega square, which is equals to 1 upon LC, and omega, which is equals to under root of 1 upon LC, and omega is basically 2 pi f, that is equals to under root of 1 upon LC. If I'm considering this f frequency, then it is 1 upon 2 pi under root of 1 upon LC. Now it's clear. Okay. Now it's clear. Yeah, this is basically resonance. This is resonance condition. This is resonance condition. Just because the power loss in LC circuit is 0. Why power loss is 0? Just because there is no any resistance, so that no power dissipation. Right? Okay. Now moving to next. Using Huygen's principle, show that the angle of incidence is equal to the angle of reflection when a plane wavefront reflected by a plane surface. All right. See, as you know that a parallel beam of light, incident here. Then AE is equals to BC equals to VT. This distance is, this one is the perpendicular. This distance is basically VT, velocity into time. That is called, this one is called distance. Now angle ABC, which is equals to angle CEA, that is 90 degree, right? All right. That's why AC is common, so that I equals to R. Okay. Okay, fine. Now moving to next. Derive the expression for drift velocity and of electron in a conductor in terms of relaxation time. See, this is too much important question. You can mark our patent sign over here. See, this one This one is too much important question, just because this questions I think coming in your final examination. All right. See, see, when a conductor is subjected to an electric field E, each electron can experience a force. And what is the force? That is F equals to QE. As you know, F equals to QE. If I'm talking about electron, then this Q is negative of E. Then F equals to negative of EE. Right? If I'm talking about the acceleration, this is the F equals to QE. As you know that F equals to MA. And what about A? A is basically F upon M. So just put this F is negative of EE upon M. EE upon M. Now, just let the equation first. Now, here M is the mass of electron, E is the charge, and E is the electric field. The average time difference between two consecutive collisions is known as the relaxation time. As we already discussed, the relaxation time is same as you are moving around in your assembly hall before your prayer. That is, see, if you are talking with your one of your friend, and then after you moving around and talking to your next friend, right, or your second friend, third friend, then what is the relaxation time? The relaxation time is just when you walking from first friend to your second friend, right? That is the relaxation time. Else you are just describing something or discussing something, right? In the same way, one of the electron collide with this one, and after collision, this one is moving and collide with another electron. Then this time, when this electron collide with first electron and then after second electron, duration of this duration of two successive collision is basically relaxation time. If I'm considering the average time of this, that is tau 1 plus tau 2 plus tau 3 plus tau 3 and so on upon n, this is the average value of relaxation time, that is tau basically, tau equals to tau 1 plus tau 2 plus tau 3 up to tau n upon n. This is the equation number 2. Now, as V equals to U plus AT, drift velocity is Vd. So, Vd is what? V1 plus V2 plus V3 up to Vn upon n. Now, Vd is what? This is basically U plus AT. This is basically U plus AT. U is what? U1 plus U2 up to Un. And what about A? A is same as A, and T is basically T1 plus T2 up to Tn upon n. Right? See, the initial velocity of electron is 0. Just because electron never be in rest, initial velocity is 0. So that first term is 0. Then what? A t, tau 1 plus tau 2 up to tau n upon n. So that Vd equals to A tau. What is this value? This is basically tau. This value is basically tau. So that Vd equals to minus EE upon m times of tau. This is basically your drift velocity. This is basically drift velocity, right? Okay. According to drift velocity expression, the relaxation time is the time interval between successive collision of an electron on increasing temperature. The electron move faster and more collision occurs quickly. Hence, relaxation time decreases with increase in temperature, which implies that drift velocity also decreases with temperature. All right. Now moving to next. Derive an expression for motional EMF induce a conductor moving perpendicular to the uniform magnetic field. This question comes in year 2023. Right? Recently this one come, and this was for 3-marker question. Okay. See, this one is also too much important question, right? See, I'm just considering this is uniform magnetic field. Just treat it, these all are dot. These dots shows the uniform magnetic field outwards. Uniform magnetic field outwards. Now I'm just skipping a rectangular conductor along with a movable arm. And which one is the movable arm? Movable arm is basically this PQ. PQ is movable arm, right? PQ RS, this is the loop, and where movable arm is PQ, moving with velocity V, inside. All right. So consider a metallic frame MSRN. So see, this one is M, this one is N. Place in uniform constant magnetic field. Let the magnetic field be perpendicular to the plane of coil. Let a metal rod PQ of length L place moving with the velocity V to distance x. This one moving with velocity V to distance x. This is basically distance of these x. Then what? Phi equals to flux changes into the coil. Phi equals to BA cos theta. Now A equals to Lx. A equals to Lx, right? And theta equals to 0. A is basically area, L is length, and X is basically displacement, right? So length into width, that's why it's called area. Now if cos theta, I'm talking about cos 0 is 1. So this is BLX. And induced EMF is what? As per Lenz law, EMF equals to negative of d phi b upon dt. d phi b upon dt. So negative of d BLV upon dt. B and L are constant, so moving outward, this one is dx upon dt. And what about this dx upon dt? Dx upon dt is called velocity. Alright. As the rod PQ moving towards left with a velocity, so that putting a negative sign also. E equals to BLV. E equals to BLV. I said though. E equals to BLV. Moving to next, a 5-marker question. This one is also most important questions, right? State Gauss law in electrostatics. Derive an expression for the electric field at a point due to an infinite long thin charge straight wire using Gauss law. See, this is a infinitely long wire. Just consider a Gaussian surface. What is Gaussian surface? Gaussian surface is just a surface which covers symmetrically this conductor. All right. And if I'm considering this one is infinitely large, so just put dot 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 dot. Now, if I'm giving the charge, this conductor charge, the charge is spread out over this conductor uniformly. Now, we have 3 surfaces. First surface is this one. If I have a cylinder, then I have 3 surfaces. Which 3 surfaces? First surface is above this cylinder, second surface is below this cylinder, and third is lateral surface. So electric field is always outward. And what about the ds vector? Ds vector is above. For the bottom surface, ds vector, that is ds2 basically in downward direction. And what about electric field intensity? Electric field intensity in the same direction, right? Now, coming to another surface vector, that is ds3 vector and E vector, both are in the same direction. All right. As you know very well, phi is equals to what? This is E ds cos theta. So here this one is 0. Here phi is equals to 0. At phi 2 is also 0. Phi 1 is 0. Phi 2 is 0. Only I have phi 3. So if I'm considering phi equals to what? Phi 1 plus phi 2 plus phi 3. That is the flux moving outward from the top of the surface, flux moving outward from bottom of the surface, and flux moving outward from the lateral surface. As you know that phi 1 is 0. Why phi 1 is 0? Just because phi 1 is E ds1 cos 90 degree. At phi 2 again see E ds2 cos 90 degree. And at phi 3, this one is E ds3 cos 0 degree. So this will be 0, this will be 0. So phi is equals to E ds 3 cos theta. As we all know, what is the lateral surface area of cylinder? ds3. If I am integrating this, what is the value of ds3? So ds3 is basically, ds3 is basically 2 pi rl. 2 pi rl. So integrating both sides, this consider a d phi ds. This is phi is equals to E 2 pi rl. And what about cos theta? Cos theta is 0, so that its value is 1. The value of this one is 1. So phi is equals to, you have phi equals to E 2 pi rl. Now from Gauss law, what do you know? Phi is equals to 1 upon epsilon naught times of total charge present inside. Now here lambda equals to Q upon L, just because charges are distributed on the rod, so that lambda is the linear charge distribution. This is linear charge distribution. So calculate the value of Q. Q equals to lambda times of L. Now putting here, this is phi, which is equals to 1 upon epsilon naught times of lambda L. This is equation number second. This is equation number second. From first and second, this one is the value of phi and this one is also value of phi. This is E 2 pi RL. From equation first and second, you will get what is E times of 2 pi RL, which is equals to 1 upon epsilon naught times of lambda L, right? The value of L cancel out. E, which is equals to 1 upon 2 pi epsilon naught lambda upon R. This is the value of electric field intensity due to a infinitely long straight current carrying conductor. All right. So don't write in red color as it is not visible. Okay, fine. If you are not comfortable with red, then I will use different colors, right? I'll use different colors. Don't worry. I think it's visible. I'm also watching my video, so I read your comments. So it's visible properly, I think. But you are not comfortable, then it's okay. Don't worry. Yeah. This is the final answer for that question, right? You already derived. Now moving to another question. This one from 2024, and this is 5 marker question. A sinusoidal voltage peak value is 283 volt. Frequency is 50 Hz. Is applied to a series LCR, which is R equals to 3 ohm, L equals to 25.48 mH, millihenry, and this one is microfarad. This is millihenry, this one is microfarad. Let's convert into its proper unit. Now, first question is impedance of the circuit. Second question is the phase difference between the voltage across the source and the current. And third one is the power factor. See, this is LCR circuit. So, calculating one by one. Firstly, we will going to calculate Z, impedance. Z equals to what? R square plus XL minus XC. So, first calculate XL and XC. See, omega equals to 2 pi V or 2 pi F. Value of nu basically given that 50 Hz. So what about omega? Omega equals to 2 pi nu. That means it's 50 into 100 pi. This is 100 pi, right? And what about XC? XC is 1 upon omega C basically. So 1 upon omega is basically 100 pi, and the value of C is 786 into 10 to the power minus 6. Why using 10 to the power minus 6? Just because C is 786 into microfarad. That's why using 10 to the power minus. In the same way, if I am talking about XL, which is equals to omega L, that is the value. Omega is basically 100 pi, and the value of L is given that 25.48 25.48 and in millihenry, so that using 10 to the power minus 3 for converting into Henry. So just put it here, 3 square plus 8 minus 4 square, that is 5 ohm. This is the impedance of the circuit. Phase difference, tan inverse XL minus XC upon R. Tan inverse 8 minus 4 upon 3, that is 4 upon 3. 4 upon 3 is about 4 upon 3. See, 4 upon 3 is about 53.13 degree. And power factor, that is cos 53.13, that is equals to 0.6. Alright, this is 0.6. Now, moving to next. What is rectification? From 2023, what is rectification? Draw the circuit diagram of full wave and working of full wave rectifier, as we already discussed this question. And see the pattern, recent question pattern for the 5 marker question. It's not a theoretical question. This question comes into the part, that is, this is for 1 marker question, this is for 2 marker, this is for 2 marker. That's how complete the 5 marks. All right. Okay, sir. So we already discussed this question. Let's move to next question. Already discussed this question. So can we move to next question? Now, let's discuss model sample questions. These are the model sample questions. These are the model sample questions. This is also very important questions from your model sample, right? See, derive the expression for effective focal length of 2 thin lenses kept in contact. If I'm considering 2 lenses, first one is this one is second one. This is second one, right? For first one, the focus is this one, right? This is called, let's see, V dash. And this one is basically V. Final image is this one. So 1 upon F1 is equals to 1 upon V dash minus 1 upon U. U is the distance from object and V dash is the image. V dash is the image by first lens. Image by first lens. This is equation number first. What about 1 upon F2? See, the image of your first lens is treated as the object for your second lens. So final image is V, 1 upon V minus. What about U for the second lens? See, for L2, this V dash is treated as the distance of object. So that this is called V dash. This is equation number second. If I am considering 1 upon F, then it would be 1 upon F plus 1 upon F2. So 1 upon F is equals to 1 upon F1, that is 1 upon V dash minus 1 upon U plus 1 upon V minus 1 upon V dash. These two cancel out. That's why it's called 1 upon F, which is equals to 1 upon V minus 1 upon U. So final resultant will be 1 upon F1 plus 1 upon F2. 1 upon F1 plus 1 upon F2. Right? Okay. Let's moving to next question. In the figure, EV and EC are the valence band and conduction band. This is the valency band and this is the conduction band EMFs, right? Extrinsic semiconductor. E is the energy state corresponding to the impurity present in it. The impurity present, it can be. Which impurity present here? This is arsenic, indium, phosphorus or antimony. Arsenic, indium, phosphorus or antimony. This one is antimony. This one is antimony. All right. Moving to next. Below are the two statements related to magnetic flux and magnetic field lines. Statement 1 is the net magnetic flux through any closed surface is 0. Okay, and the second one, the number of magnetic field lines leaving the surface is balanced by the number of lines emerges it. Which option is the correct one? Both statements are correct, and second is the complete explanation of first, or both statements are true but second is not the complete explanation of first. Third one is statement 1 is wrong, statement 2 is correct, and the fourth one is statement 1 is correct but statement is wrong. So both statements are correct. First one is the explanation of, second one is the complete explanation of first. Right, A is the correct one. Rani, you're correct. Rani, you're correct. Okay. Okay, Manish. Let's moving to next. When a light wavelength of 400 nm is incident on a photosensitive surface, the stopping potential for the photoelectrons emitted found to be 0.96 volt. The light wave length 500 nanometer is incident on a same photosensitive surface. The stopping potential found to be 0.34 volt. Calculate the Planck's constant given the speed is 3 into 10 to the power 8 meter per second and E is the 1.6 into 10 to the power minus 19 coulomb. Now see, given that lambda 1 that is 400, lambda 2 that is 500, right, nm. So that converted into meter, just multiply 10 to the power minus 9, 10 to the power minus 9. Stopping potential V1 is 0.96 and V2 is 0.34. Now, speed of light and speed of, energy of charge given, right. Photo equation E1 minus E2 that is equals to, this one comes into del E which is equals to E del V, right. Del E that means what? E1 minus E2. E1 minus E2. E times of V1 minus V2. This is given in question. This one is also given in question. That is E1 minus E2, that is 9.92 into 10 to the power minus 20. Now, come to the photo energy difference formula. That is basically del E which is equals to, okay, I think it's not visible. So, see, del E which is equals to HC by lambda. But what we calculate HC 1 upon lambda 1 minus 1 upon lambda 2, just because I have two values of lambda, right? So E1 minus E2, H 3 into 10 to the power 8, 1 upon 4 into 10 to the power minus 9, 1 upon 500 into 10 to the power minus 9. Just solve it. You calculate H into 3 into 10 to the power 8 into 0.5 into 10 to the power 6. Now just E1 minus E2. This one is also the value of E1 minus E2. Just put it here. Just put it here. Just put it here and solve this for H. Solve this for H. Okay. This one is 6.61 into 10 to the power minus 34. Okay. See, this is basically calculating the value of Planck's constant. We are just calculating the value of Planck's constant. All right. D boss. Okay. Draw typical hysteresis loop for a ferromagnetic material, the corrective fields in it. See, this is the hysteresis loop. What hysteresis loop tell? It's basically the proof of the magnetization and demagnetization is not a reversible process, right? In magnetization, we have this curve, right? We have this curve, but in demagnetization, we have this curve. So in magnetization and demagnetization, there are two paths, two different paths. So that this one is called correctivity. Correctivity. All right. Derive the expression for electric field at a point due to infinitely long charge. See, this is that's why I am calling this one is very important question. This is the same question as we discussed, right? Okay. This question, as earlier we will discuss, right? State Huygens principle. State Huygens principle. We already discussed, right? Okay. Draw a neat label diagram of AC generator. Draw a neat diagram of AC generator. See, basically in AC generator, I'm just showing the diagram and workings of this. See, this is your north pole, this is your south pole. Just put it here, armature with slip rings. Slip rings, that means I have two different rings for both the ends. This is A, B, C, D, and these all are connected over a shaft. Connected over a shaft. All right. Now, just put a carbon brush over here, and connect it. See the working. See, as you know, the magnetic field lines from north pole to south pole. This is the path of magnetic field. This is AC generator. AC generator, that means we rotate this generator and we collect the current from, right? This one, mechanical energy converted into electrical energy. See, if I am moving AB inward and CD outward, see, in this way, AB inward and CD outward, what we are applying? A right hand rule. See, if I am considering thumb inside and this finger in the direction of magnetic field, then middle finger shows downward. That means what? If AB moving inside, then the direction of current from B to A, this one is S1, this one is B1, B to A, S1, B1, AB inside, then path of current is BA, S1, B1, and galvanometer in this way. This is B2 and this is S2, this is B2 and this is S2, B1, B2, S2, D. That's how complete half of the rotation of AC generator. When CD comes at left hand side, then this one at the same like, this one is the same like, see, after half rotation, what is going on? See, AB moving right hand side, CD at left hand side, this one connected with the brush B1, this is connected with the brush B1 and slip ring S1, and this one connected with brush B2 and the slip ring is S2. Now this is galvanometer. See, again the direction of magnetic field from north to south. This time CD moving inwards and AB outward. CD moving inward, AB outward, applying right hand rule. Again current in CD branch from C to D, from S to C to D, it comes at S2, B2, and then after in this way at B1, S1, A. So if CD inside, then the direction of current from CD, S2, B2, and in galvanometer, this time the direction of current is anti-clockwise, right? B1, S1, AB. All right. If this is DC generator, then we use commutator at the place of slip rings, right? Commutator at the place of slip rings. See, this is the final diagram you are given. All right. Now come to the topper's answer sheet of 2019. See, we already discussed a lot of questions and we understood how to write the answer in your answer sheet so that you will get maximum marks. For that, I am using the master copy of master set of toppers answers. All right. So let's see how toppers write in their examination. Right. See, this is the front page of your answer book. Right. Men's answer book. This is the front page. As you know, there are some basic details you have to fill in the front box. Right. Then after this is your marks distribution page. This is your marks distribution page. See, many of the students try to solve same question multiple times, right? You will try 3 marker question at 4th page and later on the same question at 10th page or 12th page. So avoid this, just because once the examiner check your question, suppose you are repeating the question number 14 2 times. So first time when examiner checking your question number 14, just putting the marks over your front page, right? Putting the marks over your front page, and again the same question you are repeating, then they check, but when comes to your front page, they see already it's filled. They see it's already filled. It's already filled means repeating that question. So it's your failure, right? It's your failure. So moving to next. See, this is how the answer sheet. This is the main answer book having 22 number of pages. Additional answer book with 3, total 25 pages used to answer the subject code 33, that is physics. See, this is the basic instruction. This is the basic instruction, as you know, given in question paper, right? So see how to write. Very clear, impactful, and not giving much data. Why am I using much data? Just because just read the question and answer that question in the proper manner what they ask. See, this is basically a part A, marking part A in the central top. This is question number first answer, Coulomb's law. Coulomb's law states that force of attraction or repulsion between 2 point charges has the magnitude which directly proportional to the product of their magnitude of charges and inversely proportional to the square of distance between both. All right. F is equals to K Q1 Q2 upon R square. Is it? For next question, see, for next question, for third question, just see expression for the force acting on a moving charge. As we already discussed these questions also. See, just putting all these values, then after write the correct expression for it. Write the correct expression for it. Right? Now see, question number 4th, 5th, and so on. Each and every question writing in proper manner, in detailed way. There is numerical, there is a conceptual question. Let's come to the diagram based question. Let's come to the diagram based question. See, this is the diagram based question. This is a simple microscope. Drawing completely with using scale and pencil, right? Using scale is compulsory, right? In ray diagram especially. Draw the diagram of simple microscope. Then after putting here what is the HI represents, HO represents U1, D, F, and each and everything. Each notation you have to describe. You have to describe each notation, right? This is the proper way to answer in your board examination. See, similarly in difference, if they asking the difference between n-type and p-type semiconductor, just putting n-type semiconductor, p-type semiconductor and draw a line in between them, then just comparing the properties, right? All right, first point, second point, third point. See, if you want to score maximum marks, then you have to write your answer in bullet form, that is in point form, right? Just avoid a long theoretical answer. If you have long theoretical answer, then you have to put some points, right, divided into some points. That's why it's easy to read, easy to check, and it's better representation. Okay, okay, in same see, this is the theoretical question. Basically this is also a theoretical question, right? Now coming to a 5-marker question or numerical type. See, in this type question, again writing an expression and again explaining the notation, what is ME, what is N, what is Rn, right? Okay, okay, fine. This is block diagram. Basically this is block diagram, right? As everyone knows, this is Gaussian theorem. This is Gaussian theorem. See, Gaussian theorem, just putting the statement of Gauss theorem, then draw a diagram, then after just consider all these things, considering a thin uniformly charged shell of radius r and each and everything in paragraph form, right? And then after derive the expression. See, that's how this one, I think, incorrect portion. Yeah, that's how derive this expression. See, how to check your answer book. Examiner, first line and second line, third line, fourth line, each and every step checked by the examiner. So write carefully, write in proper manner, right? This is another question. This is a uniform, this is a charge carrying conductor and we have to calculate magnetic field at a point at the axis of that conductor. This is also an important question. See, draw a diagram. After draw that diagram, write the consider statement, considering a circular loop with radius r and the point P, which is x distance from the center of this loop, right? Then after, according to Biot-Savart law, properly write Biot-Savart law, expressing them. Then after, use here r square. What is the r square? What is the r basically, right? I think you can stand how to answer properly in your PU second board examination, so that you will get maximum marks, right? Just upload the PDF of this session. You may download the session PDF from the link given in description box, and just go through all these slides so that you can evaluate yourself where you stand and how you present your questions in answer book, and what strategies or how to present toppers the same question in their answer book, right? Just compare it. All right, so let's close this session. We'll meet in another session. Then after, we're going to discuss more number of questions. So I hope this session is important for you and helpful in your final examination. So we'll meet in another session. Thank you so much. Bye bye. Take care, everyone.